right, welcome to our first day of Exponents. So a lot of this should be review and look pretty familiar to you, and it's going to get more in-depth and more complicated as we go forward and eventually get into rational exponents. But today we're looking at integer exponents, so whole numbers. So off the bat, remember anything to the 0 power is 1. And when we have negative exponents, which we try to avoid, we make them positive by moving their location, switching their location in a fraction. So if it was in the numerator, it moves into the denominator and vice versa. So also quick review of these different properties. When we multiply like terms, we add their exponents. So that would be m plus n. If we have terms inside a parentheses being raised to an exponent, we distribute that exponent to everything inside the parentheses. If we are raising an exponent to another exponent, we multiply those two exponents. If we are dividing like terms, we subtract their exponents. Again, if we have something in parentheses being raised to an exponent and it's a fraction, we still, again, distribute it into the top and the bottom. And if we have a fraction and we're raising it to a negative exponent, so we're still going to distribute that negative exponent, but we want positive exponents. So to rectify that, we switch the location. So raising something to a negative exponent, you're going to distribute it and you're going to end up flipping your fraction. So let's jump into some examples. 4 to the 0 power, remember that is just going to be 1. But 0 to the 0 power, this is something that mathematicians argue with. Some people say it should be 1 because anything to the 0 power is 1. Some people say it should be 0 because 0 times anything is 0, or it's undefined. In any case, this is a highly debated topic about what 0 to the 0 power is. Let's look at 1/5 to the negative 2. Again, we are going to distribute that negative 2 into the top and to the bottom. And we don't want negative exponents, so this is going to give us 5 squared over 1 squared, which is just 25 over 1, or 25. D, nothing in the top is going to change, but in the bottom, I've got this 3x surrounded by parentheses being raised to the negative 2 power, which means both of these are going to be to the negative 2 power. We're going to distribute. And then again, I don't want negative exponents, so I'm going to move those all to the top. So that's going to be 3 squared x squared, and 3 squared is 9. So 9x squared. On to the other side. Now, what's different on E from the previous one is that this negative 2 exponent is only affecting our x term. So we're not distributing anything in this problem. So 3 is going to stay by itself because it is positive. It has a positive exponent, so it's going to stay in the bottom. But this x to the negative 2, I want it to be positive, so I'm going to move it into the numerator. And that's it. That's as far as I can simplify that. Looking at F, I have 2x to the 0. Now that 0 exponent is only affecting the x term, so that x to the 0 is going to be 1, and the 2 stays the same. So I now have 2 times 1, which is 2. Then G, this is different from F because I have this whole thing protected by a parentheses being raised to the 0 power. So I'm going to have to distribute that. So 2 to the 0, x to the 0. That's going to be 1 times 1, which is, of course, 1. Then looking at H, 2 to the 0 power, that's going to be 1. X is just itself, so that's going to stay x. And y to the 0 power is also 1. So I have 1 times x times 1, which is x. All right, now the rest of these we are going to be rewriting using positive exponents. So we are going to be moving the location of anything that is negative. And then we're going to, of course, simplify. So off the bat, I like to look at it in the top first and then the bottom. So I'm going to scan across the top, and whatever stays is going to stay, and whatever moves is going to move. So 12. 12 stays in the top. X squared stays in the top. But that y to the negative 4, we're going to move that into the bottom so that it becomes positive. And now I'm ready to move on to my denominator. My camera does not want to focus today. 6 is going to stay in the bottom. That x to the negative 1 is going to move into the top. And that y squared stays in the bottom. Okay. So now I have all positive exponents, and now I'm going to simplify and combine my like terms. Starting here in the front, 12 over 6, that's going to reduce to just be 2. X squared times x to the 1 gives me x to the 3rd. Y to the 4th times y squared gives me y to the 6th. So there is my final simplified answer. Now J, there are two ways to approach these problems. My recommendation is to simplify what's inside your parentheses first, then distribute your exponents that's on the outside, or you can distribute first and then simplify. So I'm going to first simplify. Again, I am going to be moving and combining things. So this 3 on the top, that is 3 to the 1 power, of course. So 3 to the 1, u squared v to the negative 1. So let's look at what's going to stay, what's going to go. 3 to the 1, that's positive, so it's going to stay. U squared is positive, so that's going to stay. V to the 1, negative 1, that's going to move into the bottom because it's negative. And I've taken care of everything in the top. Now in the bottom, that 3 to the 3rd, that is positive, so it's going to stay. U to the negative 1, that's going to move because it's negative. And that v to the 3rd is going to stay because it's positive. So now let's combine our like terms and simplify. 3 to the 1 over 3 to the 3rd. Those are like terms, so I'm going to subtract their exponents, and it goes where the larger exponent is. So that's going to give me 3 squared in the denominator. U squared times u to the 1, that gives us u to the 3rd. V to the 1 times v to the 3rd gives us v to the 4th. And this is all being raised to the negative 2 power. So now I'm going to go ahead and distribute my negative 2. So that's going to give me u to the negative 6 over 3 to the negative 4, v to the negative 8. And so now everything is negative, so it's all going to be switched location. So 3 to the 4th, v to the 8 over u to the 6. And then 3 to the 4th is 81. And what you could do is have made this 9 before you distributed, so that would be 9 to the negative 2, which would be 9 squared, so 81. Okay. Now, I realize that they're duplicated assignments here, so I'm going to make this II and JJ for these next two problems. So II. Again, what I want to do is simplify what's inside my parentheses first, and then I will distribute my exponent. So, starting here with the 8 and the 4. These actually can be written as common terms. So 8 is actually 2 to the 3rd power, and 4 is 2 to the 2nd power. And that's going to be important later on for simplifying my math so that I don't need a calculator to do this operation. Okay, so that is positive, so that's going to stay. That x to the negative 1, that needs to move down into the bottom, x to the 1. And that y to the 4th is going to stay in the top because it is positive. We already converted that into 2 squared. X to the 3rd stays because it's positive. And y squared stays because it's positive. Okay, so I'm going to go ahead and combine my like terms and simplify. So I have 2 to the 3rd over 2 to the 2. So what we do is we subtract those exponents. So that gives us 2 to the 1 in the top. Then in the bottom, my x terms, x to the 1, x to the 3rd, that gives me x to the 4th. And then I've got y to the 4th over y squared. So again, subtracting my exponents. I've simplified. Now I'm ready to distribute my outside exponent. So that's going to be 2 to the negative 3, y to the negative 6, over x to the negative 12. And again, we're going to flip-flop everything so that we get positive exponents. And 2 to the 3rd is 8. So there is our final simplified answer with all positive exponents. Okay, last one, this JJ here. I don't have anything that I can simplify inside my parentheses, so I'm going to go straight to distributing that outside exponent here. So that's going to be 5 to the negative 2, x to the positive 4, y to the positive 10, times 3xy to the negative 4. So what I'm going to do here is, again, combine my like terms and figure out what then needs to move to one side or the other. So that 5 to the negative 2 doesn't have anything to combine with, so it's going to stay as is. That 3 doesn't have anything to combine with, so it stays as is. Then I've got x to the 4th and x. That's going to give me x to the 5th. And y to the 10th times y to the negative 4. Again, add those exponents. 10 minus 4 is 6. So the only negative number or exponent I have left is this negative 2 on the 5. So the 3x to the 5th and y to the 6th are going to stay in the top. And we move 5 to the 2 in the bottom, which is 25.